mind. There's a little main screen, and now we got math. Okay. All right. For the first ones, I think for time purposes, we'll leave you be. Hopefully get some group responses if I ask it. But we're on a Monday here, so I'll leave you go with just focusing on your notes and making sure you understand the importance of it as we move forward. So boom, boom, boom. Okay. So first one, I'll hide this. Yeah, sorry. Okay. So actually, first two, just want to make sure you weren't frozen up there. I'm going to zoom in on these a little bit more. What kind of factoring is that? Number one immediately starts with a G. 3, 2, 1, go. GCF. And you don't have to, but it's probably smart that you, okay, that's great. Great. That worked out great. That you take out a negative just so you see positive leading terms left over in case there's a next step. But in this case, there isn't. Please focus on this. Students, once we get rolling into the factoring, don't forget about GCF. And then it becomes a big problem. Like 1 and 2, once we get into the factoring, like big global thing, these are the ones that are missed the most. All right, so do be aware of that. So again, same thing, GCF. Thought I had my eraser there, and we'll try until it goes. Pull out a 3x, and then you're left with x plus 2. Good distributors are good factors. We understand that this is the reverse of distribution. If I throw this back, then that is the beginning. So I know that's right, but I don't want to do that. I just want to check myself real quick.
On the first one, I just see a 4. Is there supposed to be 4 behind there?
Yeah. Sorry, with my erasing thing, it took that out as well. Didn't catch that. Okay, now the next one. I think I'm going to take these two and do them two different ways. I think the second one's probably a little bit easier. I will show the lengthier method one more time, but I firmly believe that most of us better get here, and those that do that are probably already done. Because I know this has to be 3x and 1x. This is what drives me nuts, and it's driven me nuts about people not thinking about what factoring is. Doing a trick that they learned last year, which is fine, but then their answer is nonsensical. Like they have x and x in the first set of parentheses, and that happened to many of us on our first test. So that's where I got a problem. All right, you're not listening when I say good foiler, say it. Good factors. You're not checking that answer. You're not understanding the relationship. All right, so that's fine. So here is our method though. That's the trick. The m number is not just -4. When you have 3 in front of the x squared, it's 3 times -4. So MA factoring, if it's just x squared, and then you move on, sure. M is the last number, A is the middle, and you just got to find that combination. We'll have a lot of that going on today when we add to the concept, which you know a little bit about, but we'll get into that. So what multiplies to -12 and adds to -11? People often forget about these two basic numbers. What are they? Like what I don't know. What are the numbers? 3, 2, 1, go. -12 and 1. We always forget about 1 times. So sometimes we get locked down on that. But this is what you do. This is not what you do. First of all, I'll write this down and cross this off. These are the answers that I got from some of you on our factoring test 2 ago. You said -12 and 1. I literally would get that as an answer from a handful of you. How in the world does that possibly happen? What's x times x, everybody? X squared. What's -12 times 1, everybody? -12. It's not even close to -4 or 3x squared, the first and the last. This is what I mean about being robotic, this is how I was supposed to, this is what I was told to do, but then you screw up your steps and you write a nonsensical answer. You did like step 1, but you didn't continue. So you got to break out of that. That's why I think it's most valuable to just undo it and try to guess and check so you understand what you're actually doing. All right, anyway, 3x squared, here is the method. This is what you do with that middle term, with those magic numbers. You split up the middle term into those. Now, this is the process. I do use this when this is harder when 3x squared is instead like 6x squared or 12x squared, when there's a lot of possibilities for what would multiply to be, whatever number that is. So there is a value to this. I'm not knocking down this method. I'm saying students jack it up by not going all the way through with it. Globally, understand what you're trying to accomplish. Good FOILers, good factors, your answer should FOIL. All right? And now we get 3x plus 1, and then the remaining x minus 4. The way I look at this is a GCF, not the way I look at it, it's the way a mathematician looks at it. You pull that x minus 4 GCF out, and you're left with the 3x plus 1. Okay, what do we always look for first? 3, 2, 1, go. GCF. This reasoning, this makes this a lot easier than, see, it's easier now to deal with 4x, right? It's easier to deal with smaller numbers, right? Is a better way to look at it. And then maybe this one should have been the one I did the long way, all right? But I'm going to go ahead and try this. See, 4x squared has two possibilities. It's either 2x and 2x or 4x and 1x. I'm trying to think of that middle term, 4, 3. Yeah, I'm thinking it's 2 and 2, just by thinking of the middle term. And this is where people that are numerate can actually have an imagination of the middle term. By the way, the middle is negative, and this last is positive. So this must be a negative and a negative. Well, actually, let me rephrase that. The last term is positive, so it must be a negative times a negative. That's the only thing that really matters. And of course, negative middle term because of that situation going on there. And then the only thing I have for 3 is 3 and 1. And then I just check, does this work? And the answer is yes, it does. 2x times 2x is 4x squared. Negative 2x and negative 6x in the middle make a negative 8x. So we should be aspiring to try to break out of that 4-step factoring thing that you learned last year. And then learn the quick things. Okay, now I'm going to be honest. The next set of notes is just giving the book that you don't have, credit for making connections. All right, so the first I'm going to show you is a word type problem, but with a picture. You have to put the picture in your notes, not necessarily, but you can maybe make a quick scratch of this, and this is technically 4-1 out of the book that you don't have, like I said. Isn't someone a golfer in here? I thought someone was a golfer, right? And I think I have someone in my second hour. All right, but anyway, this is a how far the ball is away from you horizontally compared to vertically. The input is the horizontal distance, that would be the x. The y would be the vertical distance, how high above the ground it is. All right, so a couple questions on this. Ultimately, we are going to come back to our negative 16t squared formula as well, the gravity thing. This one's a little different. What point represents the golf ball before it's hit off the ground? So what will we call this point, seeing that we're using this coordinate plane to measure, vertical compared to horizontal distance? Starts with a no, everyone. 3, 2, 1, go. We don't know the beginning point on the coordinate plane. 3, 2, 1, go. Origin. Okay, so that is the origin. We're counting that as 0, 0. Before you hit the ball, it is 0 above the ground and it's 0 feet away from you, right? So origin 0, 0, 0. What point represents the golf ball when it lands on the ground? Now that's an interesting concept. Understand that the origin is 0, 0. And then this is ultimately what this chapter will help us solve in the, also in the gravity question. What point represents the golf ball when it lands on the ground? It is going to be some number of feet away from you, but 0 again for the height. So the ball is going to go up, and then it's going to go down and hit the ground again. Now, of course, in golf, if you're a golfer, it bounces and rolls. We're only counting like when it's in the air, and then when it hits, then we'll stop. Going from there. Explain how the points of point A and point A are related to the ball's distance from the ground. I kind of gave that away. distance from the ground is equal to 0 in both cases. And then that's the kind of equation we're going to end up solving on this. So just a hint that this will turn into word problems and you'll have to be able to solve different scenarios. Okay, so here's the first thing. I'm making a connection that I already did last week because I wanted to, we had an extra day I felt in there about finding solutions to equations and actually what they represent for a graph. So, recognizing solutions of quadratic equations. Why are the x-intercepts of the graph of a quadratic important to the solution of the related equation? First of all, let's zoom in on this before I see a coordinate plane. I did do a little bit of this last week. Okay, now here's more of a basic factoring. This is a difference of, say it, 3, 2, 1, go. 2 squared. This is supposed to be instantaneous, how you know how to factor this. This is supposed to be known that it's x minus 4, x plus 4 right away. No 4-step factoring, none of that. Okay, now I did kind of give this up, but I think we could just think of this as X-Intercept Form. Okay, first of all, what's the X-intercept for this set of parentheses? 3, 2, 1, go. 4, comma, say it. 4, comma, 0, 0 for y, 0 for the output. We can think of y as on that on the other side there. And then what's that one? 3, 2, 1, go. Negative 4, 0. So, but those are also the solutions to this equation. X equals 4 and negative 4 because they make the equation true. All right, and that's what it means to be a solution to an equation. I plug in 4, 4 squared is 16. 16 minus 16 is 0. 0 equals 0. True. That's why it's a solution. That's why it's the answer for the equation. The negative 4, same thing, squared. You can take it from there. But then you also know that it's related to this because this is proven that if I plug in 4 for x, I get 0 for y. And I plug in negative 4 for x, and I get 0 for y for this, which translates to 1, 2, 3, 4, the x-intercepts of this situation. By the way, what's the y-intercept? 0, comma, 3, 2, 1, go. Negative 16. So it's off the charts. I'd have to change this. Let's pretend I went by 4s and I marked it as a 4 here. Negative 4, 8, 12, 16, 2, 3, 4. And then it does distort the graph and makes it look wider than it should be or compressed, but it's actually stretched. So my scale usage kind of distorted that picture, and that's fine. That's allowed. Actually, it's not compressed or stretched anyway, but it makes it look like it's compressed. Okay, so the relationship between solutions and x-intercepts. You already know about intercept form. We're just going to build on that and go from there. So remember that word from a quiz that I picked the question on purpose because I brought up a new word, or it was brought up by whoever made that question in the quizzes when I copied it, right? Synonyms. Now we got some synonyms. We know about intercept form. So when we had it in factored form, we called that the x-intercepts. Well, really what they are called is zeros for the equation or solutions. We would understand solutions probably the best. They are the solutions. They make the equation true. They solve it. But then the big word over here is roots, right? That was the word that first time came up in a quizzes, and I made a point of it. Hey, that's a word that actually does mean zeros or solution. Okay, so these are synonyms. They almost call an x-intercept a synonym to these, but really the best way to say it is they turn into the x-intercepts for the graph when you have these things, right? So there's a lot of talk about graphing here. We're going to set up some ideas that actually encompasses the whole chapter next. So if you want to just kind of watch, that's fine. If you want to scratch down something real quick, you won't have time to write every single word. I think we know that a few different things could happen. So our first one, let's go back up here. The graph crosses the x-axis twice. I think you know what could happen in the future. What if this was going up and the vertex was above the x-axis? Would there be any x-intercepts? Yes or no? 3, 2, 1. No. Of course, the vertex could be below the x-axis and going down. And then that would be a possibility. And now your world's going to expand later in this chapter what that means. Like, what are we going to get out of maybe solving the scenario? Okay, so here's a first one. Excuse me. Here's a first one, maybe to understand a big concept here. I'm going to write this down just as a flat out. Let's take the note down. You can most certainly have a quadratic that factors to be a binomial squared. All right. So x squared minus 14x plus 49. That's your simple MA, by the way. You what multiplies the 49, same two numbers, add to negative 14 because you have a 1 in front. So it's not really a hard MA. The answer to that is negative 7 and negative 7. You better make sure now that we're solving, you get that in factored form. So it is x minus 7 times x minus 7. But then what that turns into for a solution is 7. And actually that means the x-intercept is at 7, 0, and there's only 1. This is called a double solution or a solution with multiplicity 2. But we'll wait for that concept and that name when we get to the end of the year. You're not going to believe it, but all the way into May, I hope, or maybe even before. It depends what we cover at the end of the year, but might be earlier than that. When solutions happen more than once, some special cases. But that it does. It happens twice, but you only write one x-intercept. You only write one solution. You write x equals 7. And then the x-intercept is 7, 0. Okay, so what I'm showing you is some special cases pertaining to the graph and what kind of solutions you can get. All right, and then here's the real big one. By the way, does anything multiply to 7? Then those same two numbers add to 3? No, we know a lot of things are not factorable. They don't always have to be. All of today's homework, I think, will be, just to make sure we keep consistency and, get that practice in. Okay, and we could do, unfortunately, a negative b over 2a to prove that this, and then plug it in to prove that the vertex is above, but we don't have the time for it. Trust me, first of all, you should know this parabola goes up, because it's 1x squared. Doesn't factor, when I go to graph it, the vertex is above the x-axis. So therefore, I have no x-intercepts. You're going to find out in these sections right here, 4.3 and 4.4, this doesn't have real solutions. You're not going to believe it. They are called imaginary solutions. And you're going to learn about the imaginary number. Anyone ever hear of I before? Have you? Okay. I don't know if you do it in science. An I number is huge in electricity and understanding and being able to control electricity for our purposes here in electrical engineering. So anyway, you'll find out about that. This is like globally throughout the chapter kind of idea. Today, you're going to have ones that just work out nicely. All right. And then I'm not like covering this, just kind of watch this. We were talking about how much we should show you the graphing calculator. So just kind of visualize this. Don't write anything down on this. But you can go to your graphing calculator. I think I've opened it once, have I? And put something in the Y1 screen? Yes or no? Have I ever opened a calculator? Okay, I get my cat classes and you confused. But those are the graphing calculator. You hit Y equals when you type this in. And then there's a table hitting seconds. I guess I could open up the calculator real quick, but you really want to stay away from this right now. It's going to be all algebraic with us. We'll mess around with the calculator throughout the year, but you maybe should familiarize yourself with it. Maybe do this right now. You probably can get this open faster than me here. And then I'm going to put that y equals clear. There's my cat student questions. And then get used to. So y equals is right here. Some people may have never typed this before. I think it's kind of valuable to take a look at this. So hit the y equals, and then this is how you fumble around the calculator. X is right here. And actually, when I hit it, my glorious, I mean that in a good way, um, calculator here for teaching lights up. And then squared's right here. Boom, lit up in red there. You could do the caret 2 button, but that's faster. Then it was minus 7x, and then plus 6. First of all, hopefully you know from factoring, what multiplies to 6 and adds a negative 7, negative 1, and negative 6. That means x minus 1, x minus 6. And then the x-intercepts are 1, 0, 6, 0. But let's go ahead and, what am I looking for? Oh, okay, so second table. Instead of looking at the graph, I'm going to hit second graph, and then that's the table. And that's what they're showing you here. So boom. All right, and then you can see it right there, just what I said, 1, 0, and then there's another 0. Then look at the behavior of the table, how the graph shows the symmetry. All right, doesn't always have to be that way. The vertex has to be right, like at a perfect number for that to be the case. And it looks like the vertex is in between 3 and 4, right? So it's probably 3.5 comma. All right, is what your negative b over 2a is. But that's just that point there. Then one more point to make. Look at that chart real closely. Here's 3x squared plus 5x minus 2. One of the zeros shows up, negative 2 comma 0. Notice your x chart goes by ones. What you're going to know in the future is, look at the change in y's from negative to positive. That means from this point to this point, the graph hits the x-axis. So there's an x-intercept hiding in between there. And that's because it's fractional. Right? It's not a perfect, nice whole number or integer 0. 3x squared plus 5x minus 2, you're going to have a 3x factor. So that's why that happens. So in the future, we may investigate that. For your purposes, you're just going to be factoring and solving today. And you're going to get all questions that really should work. And if they don't, then you just say unfactorable. You move on. Okay, so now what we're going to do is the main crux, the main idea, which I held my breath last week talking about this. It may have slipped out when we were doing the X-Intercept form into standard, or standard into X-Intercept form, and then getting the X-Intercepts. It's really what we're doing here. You have a bunch of polynomials in standard form, and you're going to have to factor them and then solve them, just like we did last week in a little introductory thing. But you do want to write this down. Zero product property is huge. And it is listed with that little box there. And it does pertain to this very first example that I'm going to finish out right below this. But it's absolutely true. So focusing on the zero product property, if I have A times B equals 0, then this is absolutely what has to happen. Either A has to be 0 or B has to be 0. Then that product will equal 0. One of the two components must be equal to 0 for this to be true. It's the only product property out there. There's no one product property. There's no other number that has this feature. So I know when I asked you this, and this said y equals up here, and I asked you what were the x-intercepts, you were trained to say 9, 0, because it's whatever makes that 0 on the inside. This was a little bit tougher to imagine. It's just a fraction. I don't want to embarrass myself, but I think it's negative 2/5. My brain on a Monday. So what you can do now is say, all right, how come this is still a y-intercept, but also a solution? Because y is 0. And then if I take this and set this equal to 0 separately, this or that, and solve them. By the way, the parentheses are useless, but I'm going to go ahead and put them in both cases. Solving each one, I do end up getting my x-intercepts as well. So let's look at this in this way. Subtract 2, Please don't forget the opposite operations. I get people making negative errors all the time. Not negative bad errors, negative number errors. These are solutions or roots. That's just like a vocab thing. 9 is a solution, negative 2/5 is a solution. But as X-intercepts, this is why I'm a jerk about putting it in coordinate form, because some students don't get. And my CAT students sometimes flip those two numbers when I ask for an X-intercept. But to understand why, in this equation up here, the output is listed as a 0. All right, so the output being 0, that is the y coordinate. There's the minor difference, that's the relationship between all of these terms. Okay, I shouldn't have to do 2 of these. So I'll go to B, don't even write this one down. But this is what you're going to be doing today. No graphing, we're just showing you graphical connections. You are flat out solving. So real quick, I really do have an itch to ask people stuff, make them, force their brain to think about the upcoming factoring here. All right, but if this times this equals 0, then I could say, all right, then that equals 0 or that, and then solve each case. This one is a subtract 3. I should not have to do undo operations, and then divide by 2. I will hope that you will be able to go from here to here without those 2 middle steps. Hope you can look at that and say, oh yeah, this times this equals 0. I'm going to employ the 0 product property. So how would I solve for this? Subtract 3, divide by 2. Bam. So I know I tell you to write your work. I want you to be efficient and be able to do that fast. All right? Add 1, divide by 3. Okay, so we are solving. Those are the solutions. That's all you're writing. We're not talking about X-intercepts at all today. Okay, but it was just making connections globally for the whole chapter, so that you have that idea moving forward. And then, of course, we're gonna turn it into this. This is what I should make. I should make students answer questions at this point. Although we're down to what do we have? 15 minutes left. Damn, I cut in too much time here. First of all, class, is that equal to 0? Yes or no? 3, 2, 1, go. What can I do to get it equal to 0? Don't answer that as a group. This is what you got to do. You got to add 20 to both sides and get it equal to 0. See, because x squared and x don't combine. They're not like terms. It's not like I can isolate this and get this solved. So I have like 2 different iterations of x here. I have x squared and x that don't combine. Oh, okay, so if I add 20, now I have a factorable situation. Okay, so let's think about the numbers. Now I'm going to ask you as a group, what multiplies to 20 and adds to 9? 3, 2, 1, go. 5 and 4, 4 and 5, both combinations work. But that's not the solutions. Now this is where I get those bums that just like try to take formulas that I teach in class and just try to be fast with their answer too much without understanding each step. That's not the solutions. Those are the factor numbers. Those are the unfoil numbers that truthfully break down that quadratic into 2 binomials. So I'm going to get that. I'm going to get people say the solutions are 4 and 5 because they're going to stop short. All right, and you got to be careful with that. All right, I'll write it. I hope to gosh you never have to write this again, and I don't want you to write this. But I'm really hammering down the point. What are the solutions then? -4 and -5. Then I'm going to get the person that is a robot will ask me the question, oh, so if I get the factor numbers, then it's just the opposite of those to get the solutions? Be careful. Those are the ones that are going to make those mistakes. Show me the factor form, then think about what is the 0. I need this, and then that. Okay? This is the true factor, good FOILers, good factors. This is, the foiled or unfoiled form of that polynomial. Then move on. Oh, I don't think we need to do too many more of those. Those are easy. I'm going to skip to this one. Boom shakalaka. All right, thank you. Cool. Now, this one I claim is one we should not be doing a four-step factoring method here. All right. First of all, what do I have to do with the 15? Subtract it. You got to bring it over there. There's no 15 product rule. I get people doing that. Like they do this. Don't watch. Don't watch if you don't want to. But I'll get people that do this, and then they'll make up the 15 product rule. What are you doing? There is no such thing. There's only the 0 product rule. Get out of here. Okay, so that's a common thing that I see my seniors do. No, you got to subtract 15. Fine, I'll write this right here. And then it is going to be an unfoil. The reason I unfoil only on this, it can only be 2x and 1x. 15 has some options. Now I can just use my imagination. Notice my middle term is only 1. And then notice 15 is either 1 and 15. Imagine if you put 15 here. That'd be 30. And then this would be 1. 30 and 1 can't even come close to a middle term of 1x when you're doing your thinking of the middle term. So it's got to be 3 and 5. Who goes here, the 3 or the 5? 3, 2, 1, go. 3, because you understand 2 times 3 is 6x, and then this is going to be 5x. You can imagine, you know, your numerate, that these have a difference, these have a difference of 1. And I know I need a negative and a positive because my product has to be negative here. This is unfoiling. This is good foilers are good factors. By the way, what does the 3 get? The positive or the negative? 3, 2, 1, go. Positive. So this is what we need to aspire to be. And I would say about 25% of us are there. I know you can do this. 25% of you. I know that's the case. I, as the teacher, have to worry about everybody and get everyone on the same boat. All right? And then this is what I mean about being fast. If I set this equal to 0, I'd have to add 5 divided by 2. I want all of us to go right to that next. Set this equal to 0, add 5 divided by 2. Set this equal to 0, I just subtract 3. And those are the solutions to this situation. So that is the work I want to see from everyone. 3 steps only. Way to get to math 3, they really do want you to be efficient. You need to be efficient in order to take it to the next level. And it's a tough level. They do ratchet it up in there. So, all right, and then this one, I'm already a little nervous about 18. Like I add 18, and then this is one, honestly, I probably would do the 4-step method. 18's got a couple combinations. I could figure it out, but I think the majority might say, you know what, it might just be faster if I do MA. MA always works as long as you get the right numbers that match. You do need some calculations, you know, here 50 and 5 times 8 is 40. So that's 90. What multiplies to 90 and adds to be negative 19? 3, 2, 1, go. Negative 10 and negative 9. And then notice how nicely the middle term does break up. So since I'm fast with this method as well, it doesn't slow me down too much and alleviates that imagination thing. Like trying to imagine what are the factors or what are the things in the parentheses. Notice what I did with that minus sign, minus 10x. I made it plus a negative. Whoops. Whoopsie daisy. What's the greatest common factor of the first two? 3, 2, 1, go. X. They weren't ready for that. I was too fast. Oh, I'll leave you alone on this one. It's a negative, and it's a negative 2. And then the only way that grouping this way works, or the only way that this factoring through this MA method works, is you get the right magic numbers, and then that will happen. Those two are identical. So be and do check yourself there. I like pulling out the 5x minus 9, because it is a binomial GCF, and then leaving that. Now the whole idea of good FOILers and good factors, wait a minute. 5x squared, negative 9 times negative 2, sure, 18. I got scared for a second, but that's good. And then negative 10x and negative 9x, the whole thing I was looking for, negative 19. All right, but then the answers are add 9, divide by 5. I hope the dog that this is not like mind-blowing to you. Imagine setting 5x minus 9 equal to 0 that you did in 7th grade, and then you added 9 and divided by 5. Not being honest, that probably is like a 7th or earlier grade equation solver. Imagine setting x minus 2 equal to 0 and then adding 2 to both sides. Right, so we need to be there when we're done, and those are the solutions. Okay, let's see if I have anything of value here. If they do show this again, this is just a reiteration of what we already had as a test question. I think I'm going to go to the worksheet real quick. What time do we have? 7 minutes. Okay, so on the calendar you can see, first of all, it's good to do this, but I'm going to yank one off of there that's a little bit tougher, like a couple tougher ones. Just give you an idea, maybe a couple back-to-back. There's specific numbers I want you to do because I want to cut down your work. First of all, I don't want it to be too lengthy tonight. And then there is a key there just for answers. These are not just answer questions. Any bum that just writes answers, I know you're cheating. And just copy them. And we've already talked about that, and hopefully don't have a problem with that anymore. Oh, last year, the copying bums. Okay, where's a good one to grab? Actually, the couple that I want to grab, I gave you 6. Darn, wish there was another one like 6. Okay, so I'll take 9 for sure. Here, I'll tell you on 6 real quick. I did assign this. Maybe this is the better way to do this. I can't really zoom in on that. Look at number 6. Does that say equal to 0, yes or no? Is there a 39 product rule? No. On number 6, you're going to have to FOIL. You're going to have to subtract 39 to get it equal to 0, and then refactor. All right? Because that is not equal to 0. So that is definitely something you got to do. But number 9 does mirror 1, so I can definitely hit that one. It's really not that big of a deal. I just want to make sure that we're okay here. This program gets mad at me when I go to other programs and then stops functioning. Throws a little hissy fit. Paste. Okay, there we go. All right, so there's number 9, which I gave you the even, so it's not even one that you're going to hit here. Okay, so I get a big mess here, but we have to understand that we need to use the 0 product property. So I got to get this equal to 0. I also like positive leading terms. I'm blabbering as I see most of you write this down as our final example here. So the smart thing to do, and I'm going to say it, is to add 6x squared to both sides so that I have a positive leading coefficient. I feel like that's easier to factor. Okay, then that implies I have to take the 12 and move it over. So this one I am going to show whatever you do to one side, do to the other. And then you will get this equal to 0, so you can employ the 0 product property. This is 2x squared. So I don't know if this is necessarily something I needed to show you. Just wanted you to be aware. I think Fasola made this last year. She, had more of those questions where you got to work on it a little bit to get it where you need to be. I didn't have one question like this, but is there a GCF, yes or no? And it is what? 2. Oh no, I think she gave us a naughty one here. Mrs. Fasola. So this is funny that this happened, and I'm glad the randomness of it. First of all, in solving, did I do something wrong? Oh, that's 14. Oh my gosh. Oh, give me the Monday. I got a case of the Mondays, I guess. That's negative 14. I saw some hands go up, and now I know when those hands shoot up, I made a mistake. Nice. Okay, this does work out nicely. All right, but let me talk about this 2. Right? Hands up. Whoever hands up, made a mistake. That 2 is meaningless in solving this equation. If I'm thinking about the graph is stretched by a factor of 2. But as far as solving is concerned, I will do this once and probably never again. I can divide both sides by 2. What's 0 divided by 2 still? 0. So really, this turns into this is all I have to worry about as far as finding the solutions. So I'm overwriting this as a note person. You should essentially just get rid of the 2 when you're solving an equation. Because that's the case, and then move on to your factoring. And then I think we know that it's 4 and 3, both negative. Do understand that you do have to write that in factored form. I will get people that say the solutions are -4 and -3 because they're going to stop short. They're not going to show the factored form and prove that that's factored. So trying to talk to you about common errors so you don't make those common errors. All right, so x minus 4 equals 0. That gets me 4 as a solution, and then 3 for the x minus 3. All right, so hopefully you feel better because I did that one section from last week, like on Tuesday, taking standard form, factoring it to get it to intercept form, and then finding the x-intercepts. It's essentially the same thing.